Already we have seen some kind of technique to build an ensembles models. So the first one that already we have seen is the bagging technique. The bagging models, the main example of an bagging model is random forest. Okay, then after that we will see some boosting technique. Boosting technique models, and after that we have seen the stacking technique. The stacking technique, already we have learned this technique to build an ensemble models. Now in these lectures we will we will see the how the cascading classifiers are actually works internally. It's cascading models, how the cascading models are built internally. And so the main applications of the cascading models are used to detect the fraud detections. Main applications of the cascading models are used in fraud detections. So suppose an example. So an example of this cascading model is predict. Predict the fraud detections. Predict an example. Predict a suppose in a credit card. Suppose let's in a credit card transaction is fraud or not. Suppose let's take predict predict. Let's take in a transaction. It is fraud or not. So the main job for the cascading models is that to detect the fraud end. Okay. Now the model structure of the models each look like this. Suppose we have a given query point. Suppose we have a given query point. Suppose let's take we have a given query point xq, and we have a trained some model using our given data sets. Suppose let's take for a transactions. This is our transaction. Sorry, this is one transactions. Let's take this is our query point, and now we can easily for a transactions there have a various kind of data for a transactions that we can easily get from a and the issuing card, from the issuing company, from the issuing bank. These transactions value, various kind of transactions value we can easily got, and using this we can easily build a vector. So this is the simple query vector, and using this query vector we have applied this query vector to a build model. Suppose let's take m1. We have apply, and we have find its output. We have find its output. Suppose let's take yq. Now another thing here, actually this, if you just to see this thing that fraud or not, this actually these things are actually works internally in a binary, as a binary classifier. Suppose let's take we have to predict this transaction is fraud or not. Suppose let's take this output 0. 0 means what? It is a not fraud. Not fraud transactions, and 1, it means it is a fraud transaction. Fraud transaction. This is the simple binary classifier problem. A transaction is fraud or not. Suppose let's take the models. The models M are giving the output YEQ is equals to 0. Giving the output YQ is equals to 0. Means what? This means it is not fraud transaction. Not for transaction. And now question is how to decide this value. This is the probabilistic output, that the give the output probabilistically output. The M1 actually gives the output probabilistically. Means how the probabilistic works actually, how this probability actually works. The probability actually the M1 model is actually says that probability of the YQ is equals to 0, or the probability of YQ is equals to 1. These things actually gives the output. If suppose let's take we have apply some conditions, y not is equals to this means what? This suppose let's take we have apply some conditions here. The conditions is if the probability of yq is equals to 0 is greater than 0.99. If this probability is greater than 0.99, then we can consider only this value, not fraud. If it is smaller, so smaller than 0.99, then we can not consider this value. We can again increase this next step. We have to go to the next step. The next step what? Suppose the condition in the next step is if the probability of yq is equals to 0 less than is equals to 0.99. This is the conditions to build the next step. So in the next step also we have another model. In the next step also we have another model. The suppose let's take we have M2 model. In generally the M2 model is more complex than M1 models. So in generally M2 models is more complex. Than M1 model in general. As time increases, our complexity of the models is also increases. Here M2 is much more complex than M1. And after that if we given the M2 models also give some output. Suppose let's take models output is equals to give that output, suppose 1 means fraud. Here also we have some conditions. If these conditions fulfill, then we can take on this one. If yq is equals to 1, suppose let's take we have taken this threshold value 0.0999. If this threshold values or if this threshold value overcome these models, then we can take on this output as for transactions. Then we can stop our algorithms. Otherwise, we can in the next step we can extend this thing. The output of the algorithm in the next step extend the next model M3. Okay, the jobs are actually one, and here also M3 is more complex than the M2 model. The jobs is repeatedly doing. In the next steps at the there have also another model M4, and after something also in real world we have think at the end of the day we have an human that have taken the decisions, and human they have that taken the decisions. Actually what will is the output after suppose let's take here we have applying the 10 models. If 10 models fulfill all the conditions, then we can stop our algorithms in taking the decisions. If it is not taken, if they have some confusion, some mistakes, then we can extend the thing in the next model. And also we have to mind the next level model from the previous model is much more complex than previous one. This is the main theme in the cascading classifications. So for the work of the cascading classifications is to detect the fault of a transactions, to detect the fault of a systems. This is the main job that work actually to build a cascading classifier. Okay, this is the simple structure of the cascading. So the main concept of the cascading model, the main thing that I have used by build a cascading model is that it is mainly typically used. These things are typically used when the cost of making mistake is high. Suppose suppose let's take in a medical in applications of the medical. Suppose let's take we are interested to build a model that predicts the cancer of a patient. If they have some mistakes, then what? Then we can there have a life, that is the life matter of a patient. So the mistake of our models is we have to give more cost of that. So typically these things are used when the cost of the when the cost of making a mistake is high. At that situations, we are using the cascading model. Okay, and in mean applications, example, medical domain. Mainly in medical domain, that's are applicable. Or fraud detections. Of a transaction. Fraud detections of a transaction. That's things are actually needed. Okay, so here latency is not matter, but the matter is the accuracy. That is the main thing. So suppose let's take as an example medical domain. Suppose let's take we are interested to build a model, suppose cancer predictions. Because we have given query point for some laboratory test result, some patient conditions, something like that, something like data we have collected to build that models. And after this query point, on this query point, we have using the cancer data, already we have built some models. So M1, first we have applying this model on the query point on the model M1, and there we have taken, and there we have given some conditions, some threshold value, some conditions, and if this is on fulfilled, then we have taken some output of it. If it is some mistakes from here, then we are passing the data from the next model, and the next model is much complex than the previous one. And if this fulfills some threshold value, some conditions, then we have taken its output from these models. Otherwise, we will convert these things from the next model. The same things also here. And at the end of the day, the things are checked by if any things have mistake, if any small mistakes are confused, if our models have confused something, then it is passed the next one. If this thing is confused something, then it is passed to the next one, and at the end there have the doctor that will check the actual output is correct or not. That's the filter we are used, that's the level we are used. First level, if first level success, all the things are correct, then our threshold value, it is cross our threshold value, then we have taken its output. If there are some mistakes, then we have passed to the next level and checking to the another next more complex models. If these models, more complex models, fails to detect something, so it's passed to the next models, and at the end of the day we have human to take the decisions, it is correct or not. So that's the main concept of the cascading model. So there have also another kind of so suppose let's take the training data, how the training data are coming from another one to another. Suppose let's take we have given the training data dtrain actually we have given, let's take, and using this dtrain we have built a model M1. Using this dtrain we have built a model M1. Now and on this M1 we have applying some threshold here, and using some threshold means I am using some if else conditions, some if conditions. If this suppose let's take, if this value if this overcomes some threshold value, then we can use this output. Okay, if this is not overcome, if this threshold is not over this threshold, then we will pass this output to the next thing. Also we will see, we have seen already this thing. Now to train this model, now the question is we are usually build this M1 model by using this training data. Now how the question is how to build these M2 models. Also to build this M2 model we need some data. Suppose let's take we need some data D2 train to train. Now the question is D1 and D2 dtrain and D1 ends are equal each other. No, this is totally different. So the dtrain model, dtrain data, we have used the dtrain data that we have used to build the model M1. Now the D2 data that I have taken to build the M2, that I have taken to build an M2, That is D2 trained is simple. The D trained data minus D test. The question is, what is D test? D test is simple, the data that's predict the correct output. So among all the data D trained, there have some data that also fulfill these conditions. These conditions that also fulfill. Suppose let's take the condition that fulfills this threshold value is, suppose let's take D test here, that fulfill this threshold value. So now we have extract the data. We have removed the data from our original data sets and built a new data set. And using these new data sets, we have trained our model M2. We have trained our models M2. Okay, that's now the same things also we have doing here. Now the same thing in the next step, what we have doing? We have also some threshold value here. If some threshold, suppose let's take it's theta 1 threshold. Suppose let's take it's the some threshold theta 2. If this is fulfilled, we have taken its output. If otherwise, we can transfer this data to the next models. Now also we need here some data sets to train this model M3. Suppose let's take D3 train, that we have need. And also after if the data that we have not fulfilled these portions, we have transferred from here to here. And also on this D2 train data, we have some data that have some data that fulfill this threshold value. Suppose let's take this threshold data is D double dash. Now to build the D3 train data, we have to extract, we have removed the D double dash data from the D2 train data to build this D train data. And now using this D3 train data, we have built our M3 models. We have to build our M3 models. That's the main job actually iteratively doing. We have to doing this stuff. Okay, so this is a simple concept that how the cascading models are internally doing, and how this how the training algorithms are doing on cascading models. That's depend on the situations. And these things are the threshold values we have chosen by using some expert of the domain knowledge. We have to need some domain knowledge of this. The medical, if we using these cascading models on a medical domain, then we have to consult to the doctors, and how much accuracy we need to build an output, how much confidence we have need to take this output. Okay, if you given that some transaction, if we build some transactions model, then we have to take the decisions how much parameters we actually need to confirm the transactions is correct or not, and from which source the amount is coming, and from where this amount are going. So all the things we have to maintain, all the parameters of the situations we have to take the mind. Okay, after that we have to build these things. So these the thresholds value, and all the things, all the models and all the situations, and which models we have to choose, all the things are depends on our domain knowledge and domain experts that's are needed. Actually at the end of the day, we have needed a domain expert to build this cascading model. Okay, and after some failure cases happen, then also we need some domain experts to predict its correct output. Okay, and they have another kind of cascading model. So this is the simple iterative cascading models that's depend on the previous stage, but there have also another kind of cascading models. Suppose let's take we have a query point xq, and using this query point, query point or the train data, we have built a model M1. Okay, now we have defined some threshold conditions. Suppose let's take I am using here P naught. P naught means simply probability of our yq is equals to 0. This probability I am taking here P naught. P1, these things means probability of yq is equals to 1. These are the two things. So the M1 means what? M1 means P naught of, if P naught is less than is equals to, suppose first take this output, first take this final output. Suppose let's take, we are declaring here our yq is equals to 0. We have declared here, means what? If our p naught is here greater than 0.99, if these thresholds are overcome, then only we can take this output. Otherwise, no, you are go to the next step. And so if the some things are failed here, if suppose let's take, we have taken some threshold, if less than is equals to 0.99, and if it is greater than 0.9, then only we can using this model. Otherwise, if suppose let's take, if our p0 is here less than is equals to 0.9, then we are using the m3 model. Also there have chance. So it is the depend on the, suppose it is the simple the nested if else condition. So suppose first we have checking it, if the conditions, these conditions are fulfilled, then we give the return this one, else we checking these conditions. If these conditions holds, then we send the data to the m2 model. Otherwise, else these conditions hold, then we send the data m3 model. This is the simple the nested if else conditions that already we have seen to build a decision tree. So simple the models, if you write these models, if first we have conditions, if our p naught is greater than 0.99, then we have given the return yq is equals to 0. Otherwise, else we have taken the nested if our p naught is greater than this one 0.9, then we use the model m2, else if p naught is less than is equals to 0.9, we use m3 model. This is the simple one. Next, so this is a simple nested if else loop that we have to use. Oh, this is the another kind of cascading model, this is the another kind of, but actually the internal work are actually the same, but just the things are different, but the internal work are actually the same. Here you have some simple, instead of passing to the next model, so we have checking here, we have apply some conditions. Here instead of passing to a singles model, we are passing the data to various models. This is the main thing that app would doing here. But the internal job that are actually doing here are the same. So, but the limitations is these cascading models are totally depend on the domain experts. Actually, we have needed some huge amount of domain knowledge. Only then we can use these cascading models only on that. And at the end of the day, after if we have some amount of confusions, then we can pass these things to any human decisions. Okay, so this is the simple, I think the main motto, I mean the concept of cascading models, how these things are actually internally work, the intuitions and the pictorial value, how these things are actually doing these jobs. I think you have already understand these things.